And there's this other one. New Year's. Yeah, it's I just saw it on Facebook and I was like, and then it's just like also five days after. And then it's like that is. Yeah, that would be interesting.
I don't know how to do it. I don't know how to study for that. Okay, so I'm not sure last time
Wait, you guys finished your code? Yeah. Fuck you. Sunday hours. It's a month for the target. Then you can like. I was like, I was telling someone. Later, we have to get it 20 and then truck. Oh yeah, like I was, it took me like 2 hours to Oh yeah? How many? It's like bucks. It's like
Hey. Hi, everybody. Oh, is everyone excited? Finished phase 1. It's all done, all behind you. That's great. You guys did really well. We looked at this course on WebCat, and it seems like a lot of people got 16, 20s. So that's fantastic because we really expected you to get up to about JSON, but maybe struggle with JSON and not complete it. I felt like a lot of you guys succeeded at that. So what we're going to talk about today, here's kind of the really detailed outline. We'll cover phase 2. We'll talk about, why are we doing this? Why are we torturing you with this big project? We're going to talk about how phase 2 will get marked. It's going to be rather different from phase 1. What you need to do exactly. And then we're going to dive into some coding concepts, which I put up on the board as well. We're going to go through some of the concepts that appear in Android applications that you have to be familiar with. You don't have to be familiar with them to a point where you create, new objects or asynchronous tasks or anonymous inner classes, but you have to be able to read those things and recognize what, for what they are. And then the last thing is how to really get started on the project, how to do well on it. This phase of the project is going to be 3 weeks. You have a really long time to work on this thing. So there's a couple of no-nos, like procrastinating and starting 2 days before, because this time it really won't work. And then there's a bunch of good things you can do to improve your chances of success. So to start with, let me just give you this demo, partly because it's working. And with demos, you're never quite sure when it's going to stop working. So what are we looking at? So this is the Waldo service. This is the Waldo application that you're building. Okay, so prior to this, you were really building parsers in phase 1 that would kind of comprehend, extract data from the TransLink API. And this API talked about routes and buses and bus stops and all this stuff. So now we have this kind of visual application that is going to consume a lot of this data. And in addition, there's another service called the Waldo service that I'll describe to you, which we built ourselves, which supports things like remembering your location and then sharing your location with other people. It also does things like sending messages across and stuff. So it supports a bunch of things that you may want to include in this app if you're interested in bonus points on the project. So basically, what I have here is this Waldo app. I can click on the left, and I can bring up a couple of things that I may do. So I can find the Waldos. And finding Waldos, well, Waldo stop. Welcome to demo. Cell demo number 5. Make sure my internet is working. So this is where you start. So this is me. This is the user. And if I do find Waldos again, voila! All right, it worked. So here are my Waldos, right? I got just 2 Waldos right now. They're these anonymous user things. I can click on a Waldo, and this will give me the Waldo's name. So this is a message on init session bot. So there's a couple of bots that are preceded on the Waldo service. And then the second one is a stationary echo bot. And so this tells you, first of all, you know where they are, so you plot them on the map. And then you know their names and when was the last time you heard from them. And then for a Waldo, you can also get the route to a Waldo. So this is where a lot of translink magic comes into play. So this is where you're going to find a direct bus route between you and that Waldo. Okay, and then you're going to plot it on the map. So this pink thing that goes approximately between me and approximately this Waldo is the bus route that takes me to Waldo. And there's 2 bus stops. So these kind of pinpoints. So I can click on a bus stop and it says, take bus 41. It's departing right now. So I can hop on it right now and I can make it to my Waldo. Or I can click on the other bus stop and find out how that Waldo can get to me. So this is where the 2 web services interact. So I'm pulling data from the Waldo service to find out where these Waldos are located. And then I'm using the TransLink API and pulling live bus data to figure out what buses can I take to get to a certain Waldo. So you're going to be putting all of this together and creating this, not from scratch. We give you code to begin with that creates a lot of this UI for you. So you're going to have to deal with a lot of the logic, right, in this program. One additional feature that this supports, you can press on yourself, and then you can find out the messages that you've received. So, for example, message on init session bot says, hello there, welcome. And then message on get Waldo says, glad to share some Waldos with you. Okay, so there's these Waldos, and then they can also send me messages, and I can check my messages. And after I check them, they should go away. So if I check my messages again, I have no message. Okay, so pretty simple app. We allow you to modify some settings about the app, like you can change the number of Waldos that you fetch from the server. Right, so there's like 5 of these bots or so. So you can try to display more than 2. You can try to display 5. And then you can change maybe the stop distance that you're willing to accommodate. So if you're looking for a route between me and Waldo is in the same building or next to me, then you shouldn't be returning a route. You should just say the Waldo is within walking distance. So there's a couple of these kind of corner cases that you have to deal with. I'm going to describe all of this. So this is the app, right? So I can find Waldos again. So now, bam, I have 3 Waldos. And there's this extra Waldo here that I haven't seen before. So that's basically the app that you're going to be building. So why are we doing this? So the point of the project is to really bring together a bunch of concepts, right? So you were dealing with event-based programming in the Zax parser, right? And then you're dealing with event-based programming in phase 1. So in this one, there's going to be a whole lot of event-based programming, right? It's like ubiquitous in the Android platform. And really, any large framework that you're going to be dealing with is going to have a lot of event-based programming. So this is going to be a chance for you to practice that. As well, there's going to be, data structures and models, and so you're going to have to, figure out how to manipulate models. You're going to have to figure out how to read large amounts of code that we're going to give you. So you're going to have to kind of manage that complexity. And then obviously, this is a pretty large-scale project. So from a project-oriented point of view, this will give you this will develop some of your techniques for dealing with large code bases. So you have to test often, right? How do you debug a problem if you run into a problem? I mean, you've seen a lot of these in phase 1. In phase 2, all of it is just going to be exacerbated. So it's going to be more difficult to debug your project. This emulator thing sometimes breaks. Sometimes it takes a long time to start, especially if you have an older laptop. So there's a lot of things that may go wrong, and so you have to kind of prepare for these and know how to figure this out. And then finally, there's not. We give you this webpage where we describe the project, and we try to be meticulous and detailed about the steps you need to take. So this is the project phase 2 description online. But in reality, a lot of the things you're going to need to do are just not going to be documented on this page. Okay, so for example, doing things like figuring out in Android how do you interpose on a task. So we're going to be talking about asynchronous tasks today. So you're going to have to know the task API in Android, and the way you do that is by looking at the Android documentation. So we don't spell things out for you in this project, even more so than in phase 1. So there's going to be a lot of code searching and kind of dealing with new interfaces and new frameworks. So that's the idea. So this will prepare you really well for co-op experiences, for future projects, and so forth. So it's going to be really good for that. So the way you get marked on this project is there's no webcast. So we're done with webcast. Some of you might be really happy about that. Some of you may not be very happy about that. So we're looking at the webcat thing, and it's like people were submitting like mad. Some people submitted over like 150, I think, submissions. Just like incredible to me. That would take me hours, just like clicking on submit. So it seems like like the webcat thing is great for the kinds of projects that are very well specified and we can write tests for. It's not so great for something like this, which is a little bit more complicated. So it's difficult to automatically test this. So what we're going to do is in your labs, you're going to demo this project to a TA. So the demo is going to be about 10 minutes long. And in the first 5 minutes, you're going to lead the demo with your partner. So you need to, beforehand, figure out exactly what you're going to demo. So you're going to say, well, I'm going to fetch 3 Waldos, then you'll click on this Waldo, and then we'll show them that, look, the Waldo appears, right? And then I'll press get route, and then we'll retrieve the route, and then we'll show that the route functionality works. So there's going to be a script that you will create and then actually show to us and demonstrate within the 5 minutes that you've implemented the things we wanted you to implement. And then in the second 5 minutes of the demo, the marker, the TA is going to ask you questions about the code. And so unlike phase 1 where it's like, well, maybe your partner did all the work for you, in this case, you're going to have to really know the code fairly well. So the expectation is that both of you know the code equally well, and either of you should be capable of answering questions about the code that you've written. So in that QA session, we're both going to demo the features of this app, and then you're going to also explain to us what you've done with the code. One thing to note about the app, so like the route functionality, right? This thing is not perfect, right? Like this route doesn't stop exactly where this Waldo is, and doesn't stop exactly where the user is. So, this is approximately, the version that we'd be happy to see from you, right? So it doesn't have to work perfectly. This project is not about, getting this thing to run perfectly, robustly, never crash and so forth. Your demo is up to you. Right? So you get to press on this thing and tap on it and interact with it. So you get to figure out what you're going to show us. Okay, so we're not going to test like corner cases where a Waldo is, in the water somewhere. You have to take a boat. You're not going to test cases where, the Waldo is in, forest and there's no bus nearby. Something like that. So, the point here is we want to see that you work through the features and you've done the best you can on the features. Right? And really in those second 5 minutes where you explain how you've gotten to that point, that's what we're really interested in. Right? That you speak about the design decisions that you've implemented. Any questions about the project or maybe the grading scheme that we're going to use? Should be demoing on emulators. So I recommend an emulator. Less chance of things going wrong. You'll be demoing on your computer. If you get to a point where you figure out how to run this on an Android phone and you get it to run on an Android phone, that's great. You could do that as well. So either is fine. I think in the second half of the QA, we're going to need to see your code. And we're going to do a code read through with you. So for that, you're going to need Eclipse. Any other questions? Great. So that's how we mark this. So what do we need you to do? I'll switch this over. So to get this app working, we created this long list of tasks. Right, so this page is even longer than phase 1. And we'll give you longer. We'll give you 3 weeks to work on it. And so you can get here by going to the project page. At the bottom, you have phase 1 and phase 2. So phase 2 has a link now, so here's the page. And we broke it down into 9 tasks. And the final one is the submission. Right? So there's no webcam. So you won't be able to test it against a server. So you're going to have to, try it by yourself, give it to someone else to try it before you actually submit it. So for submission, if we jump to the very bottom, we basically just require that by a certain date, you submit your code, you commit it to your repository. And that's the version that we're going to use in demo. So the tasks, they're pretty extensive. So you should be reading through this very carefully, just like phase 1. There's a lot of detail. And a lot of things left out at the same time. So for actually what you need to do, right here are the bullet points. So to start with, you need to be able to plot this person on the map. Right? So this person that I start with. There we go. So this person that I start with, right? That's the first bullet point. How do you plot this person on a map? Okay? The second part here is going to be interacting with the Waldo web service. So I'll be talking about web service in just a little bit. But essentially, it's kind of like TransLink. You're asking for some information, and the service gives you some information back. It's going to be in JSON format again. You're going to have to create a parser again for the JSON format. Some of you who've struggled through it and were successful, that's great. You have a leg up over other people. So the Waldo web service returns back information in JSON format. You parse it, and that information represents a set of Waldos and their locations. And so you need to now plot the Waldos on the map. The third bullet has to do with finding a direct bus route. So this is where I fetched the Waldos. Here they are. Now I want to find the route to a Waldo. So this is another API call. But this also requires quite a bit of algorithm work. Right? So the data that you have for representing a set of bus stops and the route is not like in this perfect format. Like a route is essentially represented as a set of points, and the entire route is represented as these sets of points. So you have to figure out exactly which portion of the route to show on the map. And then you have to figure out how to actually plot it on the map. Okay, so both of those are part of this third bullet point. And then the final one is to display messages. Right, so right now there are no messages, I think. Oh no, there should be some. So here's a couple of messages, so you should be able to talk to the web service, get the messages, and then show them. So showing them, like this little pop-up box that shows up, that code is already part of the project. So you don't have to create this thing from scratch. But you have to be able to parse out the messages from the Waldo web service and find out where to pass those messages so that they're shown on the screen. So those are the actual kind of deliverables that we expect you to do. There's, this kind of summarizes in detail exactly what this is. The key no-nos is you shouldn't break the functionality that's already there. Okay, so don't remove code from the project because there's a lot of dependencies in this project. So really, you're just adding new code. Don't change the menus, and things like that. So really, you're just adding extra features on top of the app. You're not completely creating a new app. And then I guess I'll get to this at the end. And then there's a bunch of bonus functionality that you could add, and you should look through this if you're interested in doing better on phase 2. Okay, so that's the specifics. So let me actually show you. Let me talk about web services for a little bit. So the TransLink has an API, right? And we've been using the API. But really what you've been doing is parsing the output of that API. So here's an actual invocation of this API and the output. So this output sort of resembles the JSON that you've seen, right? Not exactly the output that you were working with. But here's a call to the web service that actually gets me back this output. So I have some API key that I pass to the service, and then I have a latitude and longitude. And this gets me stops around that location. Okay, so there's some format to the service, to the specific call, and then there's some output and some output format. So if you were to try to graph this, then the way to think about it is that I have some phone, but this could also be Eclipse, right? Maybe it's not my phone. Maybe I'm running in the emulator. And then there's the TransLink service. And so the TransLink service supports certain calls, specific ones that have to do with bus stops and bus routes and so forth. So you can invoke these calls. And here I've showed you this invocation in the browser, right? So the actual URL is the invocation. So when I press enter, it actually calls to the service, and the service returns the data. So it can call to an API call, and then get back some data. All right, so this is kind of the diagram you should have in your mind. And then there's going to be another service, and that's the Waldo service. And the Waldo service is not run by TransLink. It's run by me. And the Waldo service supports a different API. And so here's a page to actually demonstrate the Waldo service. So, it supports 6 calls, the first of which is init session. So I can initialize a session either with a random name, or I can give it a specific name. So I can say, initialize a session for item. So what I get back is a little JSON string that says, okay, initialize your session, and here's the key that you're going to be using, and your current location is null. I don't know of a location for you. Okay, so what I just did in my browser, right, and this is a great way to test whether you're actually talking to the service correctly, is I actually invoked one of the calls. This call is the init session call. And I got back some data. And the data I got back is JSON. Okay. So there's a couple of other calls I can make. So now that I have initialized my session, I can get a set of Waldos. So I can specify the key that the server returned. I can say, I'm interested in 2 Waldos, so get me their information. And then you get back JSON that looks like this. You've seen JSON before, so this is an array of records. And these are going to be Waldo records, right? So the first one has a name, stationary EchoBot. It has a specific location. And it has a timestamp of when that location was generated. Okay, so I'm invoking, so this is a little page that actually helps me experiment with the service. And if I invoke this without a number, then I'll get back an error. And so there'll be a JSON to represent the error that the server experienced, right? And then I can also use this key to then, for example, get messages. So the very last call. Right. So this matches up with the application, with the Android app, right? So the messages that I just received, right? You want to show those messages when someone clicks on the user, right? Currently there are no messages. So here, if I check my messages again, there'll be no messages. So this null value for messages must correspond to showing no messages. Right? So that's kind of how this thing comes together. And it comes together in a whole bunch of Android code that we're going to go through in just a bit. You guys have any questions about services? This diagram thing that I drew? So one thing to remember is that both of the services are live. So TransLink, for example, has actual live data about buses in Vancouver. So if you query the service right now, midday, then there's a whole bunch of buses around. So, if your Waldo is somewhere on campus, chances are you can get a bus route to that Waldo. But if you query that service at night, there's not a whole lot of Waldos, not a whole lot of buses, right? So the behavior of your application will change depending on what data actually is currently served by the service. And same thing with the Waldo service. So these bots, we're going to have them move around. And they'll move around every time somebody, makes a query to the service. And then all of you are going to go online and actually add new Waldos to the service. So this data is going to constantly change. So it's going to be slightly more difficult to actually experiment with it and, check that it does the right thing because largely depend on what the service is returning. And if you have ideas for bots that do cool things, you should tell me. So that's kind of services, web services. All right, so how to actually approach this thing? So obviously the task by task breakdown is the key thing. The project that we just pushed, I think this morning, is Waldo Phase 2 to all of your repositories. So if you check out Waldo Phase 2, then you'll get the starter code, essentially, for this phase of the project. And within this code, so this is an Android application. So in order for you to run this thing, you actually have to complete the first task. So you check out the code, it's not going to compile, it's not going to work. Right? So the first step is to actually get Android installed on your machine. So this is pretty messy, right? So depending on Mac or Windows or what have you, this will slightly vary. We try to give you a whole bunch of directions for this. You have to follow them pretty closely. So our code is against an older version of Android API. So if you were to just go blindly to the web page and download the latest Android, it's not going to work. So you have to download a very specific version to make sure that the code we give you actually works and compiles. And then you have a better chance of getting it to work on an older phone as well. So let's say you installed Android, you checked out the project. What happens next? So really, there are kind of two files that you have to concentrate on. So task 2 has to do with registering for a TransLink API key. So that's pretty trivial. But task 3 has to do with interacting with the Waldo web service. So in this project, there's really two files that you're going to care about. The first of these is the Waldo service Java under waldo.waldo web service. And here you'll see a bunch of comments that say things like CPSC to 10 students. Right, so these are instructions for, hey, student, pay attention. Right? This is where you need to add code. So essentially, this entire file is empty. We just gave you some methods that we expect, and you have to fill those in. So this file is what orchestrates interaction, between your application instance and the Waldo web service. And then the second file, which is critical, is the map display fragment. So map display fragment is an enormous file, and there's a lot of complexity in it. So you're going to be adding a lot of code to it. You're not going to be really creating new classes unless you really need to. Okay. So in this file, we also have a bunch of comments for things where you have to pay attention to specific, parts of it where you have to add new code. So like plot route, for example. Here you need to implement this method and plot the route on the map. So those are the two files that you really should pay attention to and study really closely. So let's talk about some of the coding concepts within Android. So an Android is an event-based framework. So what that means is that if you look through this code, you'll see that there are going to be methods that look like this. So this overrides a method of my superclass, and the method is onActivity created. So this is event-based in the sense that you don't actually know when this method is going to be invoked, right? You don't know who's going to be invoking this method. You're just creating this method so that when an activity is created, whatever that means, this method will be called. Okay? So this is really the heart of event-based programming. You're specifying callbacks in the form of methods, and these methods are going to be invoked by some external code that you can't see. So one of the complexities of dealing with Android is that it's very difficult to actually see the call path. Right? So the stack traces that you're going to get are going to be really massive and sort of complicated because there's going to be some of your code in those stack traces, but then there's also going to be code from the Android platform. So you have to be really good at picking out exactly the classes that are relevant to you and then inspecting those traces to find out where to go to find the problem. But this is very much like the Zax parser, right? So in the Zax parser, when you added things like on end element, on start document, right? You're doing the same thing. You're creating the set of methods that you want to invoke at specific points when you're parsing the XML, and then you're giving it to someone else to actually invoke. So here you're doing the same thing, except that a lot of the methods that you're dealing with are like interaction UI methods. So when I click on a bus stop, that's a handler that's defined in my code somewhere, and Android invoked this handler for me, right? And then I have to make sure that there's code in here that reacts appropriately, like adds the information about the bus stop. Okay, so there's a bunch of these handlers in this code, so you're going to have to get really comfortable with dealing with event-based programming. So the other thing to take a look at is this concept of anonymous classes and inner classes. So you'll see code like this. So this code creates an overlay, a location overlay. So the way the Android is organized is that every visual element essentially belongs to an overlay. And then you stack these overlays together, and then you get the screen. Okay? So every time you want to add something new to your UI, you have to create a new overlay. And then you have to say exactly where in the stack it belongs. Right? And you can remove it from a stack, you can add it to a stack, and so forth. So here's a point where I actually create the overlay for an overlay that responds to long presses. Right? So if I click on the Waldo here and I just hold down my mouse button, it retrieves the messages for that Waldo. Okay? So this is handled by an overlay, and this overlay is created in this code. And here's exactly the event-based method that I defined, which reacts to long key presses. So in a long press, I'm going to get messages from Waldo, and I'm going to execute it. So this is incomplete code. There has to be more stuff in here. Right? But this is essentially what it looks like. So this code should look really weird to you. Because what I'm doing here is it's like I'm creating an object, but then I'm also defining something about this object. that's pretty weird. If it's not weird, then I don't know what you're doing. Why are you in this class? So to kind of explain this concept a little bit more, let's look at the drawing editor in Figure Drawer Complete. So you can get this project from the lectures repository. So in this case, so if you guys don't remember this, I can run this project again. Not as an applet, but as a Java app. So here's our little drawing editor, right? Very familiar. I can create a new drawing. I can create a rectangle. I can move it around, things like that. So you guys seen this before. So in this drawing editor, there's going to be a line of code that says add an action listener for a new drawing action. So this new drawing action is a class. And this class is defined at the bottom of the file. So that's the first piece of weirdness, right? Like all of a sudden I have, so that my class ends for drawing editor, and then I have another class in the same file. So this kind of contradicts what we told you before, which is that you really should have only one class per file. So this is called an inner class. And in this case, this inner class is private. So it's only visible, to this file. And the reason it's only visible to this file is because I don't use it anywhere else, right? This new drawing action just needs to perform, some tiny bit of code, like add new drawing. And it's only used, right here, where I'm going to create an action listener, that expects this kind of action listener. Okay, so that's the first thing. So these are inner classes, and you would define them kind of below your class where you would expect to use them. The issue, of course, with these is that if I have like 20 of these small classes that are necessary for me to execute small tasks, then my code will get really ugly. Because I'll just have 20 of these small classes underneath my large class. And then I'll have to jump back and forth. And I'll say, oh, well, drawing action is actually defined here, but it's used up here, right? So I have to kind of look at both pieces of code. So an alternative to doing that is to create an anonymous inner class. So here's a piece of code that does the same exact thing. And this is what appears in Android. So what I'm doing here is I'm calling add action listener. So it's just like before, right? So these lines are the same. But then instead of creating a new drawing action, I'm actually creating a new abstract action. So if you look at new drawing action, it actually extends an abstract action. So one thing I could do in my code, and this is really useful when you're dealing with UI and you're creating a lot of these kind of slightly one-off classes, where it behaves exactly like abstract action, except it overrides one method. So instead of creating a separate class to define this new drawing action, I can actually define it in line, meaning in my code where I'm going to instantiate it. So this defines a new class, and this class is anonymous because this class doesn't have a name. So there's really no way to refer to this class anywhere else in my code because I'm only using it at this specific point in code. So the way I create it is I create its superclass. So this looks like I'm creating a new abstract action, except that I'm going to give this abstract action some new method or some overridden method. Okay, so this is defining an anonymous inner class. It's anonymous because it doesn't have a name. And the way I do this is by creating a new, the syntax for this is to do new superclass. Okay, and so this code that's here is identical to the code that's down here. So I've just inlined the definition of that class in my code. Instead of defining it separately, I'm inlining it and defining it on this one line. So these anonymous classes are going to be all throughout the Android code. So here's, in the Android case, I'm defining something that extends a simple location overlay. And I'm changing one method inside of this simple location overlay. So essentially, I've created a new anonymous class. This anonymous class behaves just like a simple location overlay, except that on long press, it's going to do something extra. Okay, and then I'm also returning this thing that I just created. So you'll be seeing a lot of code that does things like this with anonymous inner classes. Okay? So you're not going to need to create it, but you're going to have to know how to read it and kind of reason through it. And set breakpoints and kind of step through it and so forth. So kind of expect you to be able to do that. One final concept in Android that I want to get through with you is that of tasks. So in Android, when I'm talking to a service, there's no way for me to talk to a service and have that functionality be implemented as part of the main program. So we're really used to writing a main statement and then have everything execute sequentially. Unfortunately, in Android, you can't actually have a request to an external service be sequentially ordered with respect to the whole execution. So it needs to be a separate task. So in Android, there's this concept of an async task. So this is going to be an asynchronous task. It's asynchronous because it executes in parallel with your code. Okay, so the way to think about it is that you have some code that you've implemented, and it executes like this, straight line. Right, so it might start in main. It executes some statements. Right? Maybe there's a call to F, and so now it's going to execute F statements. So it's very linear, very sequential. When you're creating a task, you're creating a new line. So this might be a separate task. And this task might be the init session task that you're going to use to talk to the web service to initialize your session. And so what you'll do is maybe here in main, you're going to create this thing. You're going to return back. And now you have two lines that are executing at the same time, concurrently. At some point, this task is going to terminate because it initialized the session. Right? And so it'll come back, and it's going to be done. And so you're back to one main task. So these tasks are going to be used in the service code. And the way you use them is that you extend an async task. And this async task supports essentially three methods that you should care about. The first of these is what to do before the task executes. So this is the on pre-execute method. So think of on pre-execute as the thing you call, like right here, on pre-execute. Just want some initialization behavior from that task. Then the second call is the do in background call. So you can think of this whole thing as the do in background. Right, so there's a bunch of statements here. And those statements are going to be executed in the body of this method. And they're going to be executed concurrently with the other task. So you're not going to be creating these tasks, but you're going to be modifying them. So for example, here you already see a comment that says complete this method. So this is the get route task. It needs to get the routes between two endpoints. Right? So this is a local task. It doesn't even communicate to the web service. So to compute routes between two endpoints, we're using a task. And so your code for actually that computation has to go in here. And then the last bit of this interface is the on post execute. So this is what happens after the task completes, which is right here. So these tasks execute concurrently. right? So you're not going to need to create new ones. You're just going to have to modify the ones that are already in the code. Any questions about tasks, anonymous classes, inner classes? Yeah.
So for tasks, do you sort of have to wait for the task to finish? Like before you can...
Do you need to wait for the task to finish? No, you do not. So essentially, think of it as it's like a wheel. I can spin the wheel, and it can go off and do something else. And the wheel is spinning, right? So this is a wheel. I spin it by calling create, the task. And once I've done that, the do in background thing starts executing, and it's chugging along. At the same time, I'm also executing things on the side as well. So it's executing asynchronously. Yeah.
Do you have like maybe some like method in your main that would ever like rely on the end of the task, and like what would happen if you like tried to call it before that task was finished?
Right. So there's certain cases when there's actually dependency between these two pieces of code. So you're actually calling this thing and you're expecting it to do something, and then you want to use the result on the side. Okay. So you can actually do that in one of two ways. You can either do it on post execute. So if you're depending on the result that's computed here, you can add the code here. Or you can have this task actually create a call to your main method. Right? So there's something here that says, when task done. Right? And so the task can actually execute this. And I'll run it. Okay, so the final thing I wanted to kind of mention is how to work on the project. So this thing is obviously complicated. There's no webcat that you can use. So the first rule is don't procrastinate on this thing, right? So it's not a lot of code that you have to write. Gail mentioned today that in total the Android code base, you have to write maybe 500 lines of code. It's pretty easy, 500 lines of code. Write them for like 5 minutes, right? It's not going to work, But so the key thing here is that there's a lot of complexity with the project. So you have to follow the steps, okay? The ones that are outlined on the page. If you're blocking on something, just like on phase 1, go on Piazza and post a question. Right? Google is your friend. You have to do a lot of searching. For actually debugging the program, it's very difficult to create tests for Android applications. So the thing that we recommend is that you actually rely on logging. So add print statements to your program, right? Put a breakpoint. So be really comfortable with inspecting an execution that's complex and printing out messages and then looking at the log to find out what went on. Read stack traces, right? When this thing will break because there's an unhandled exception. When the tasks go crazy, it's going to print out a giant stack trace. So you're going to have to follow it back to find out what went wrong. And then the final note is that remember that the service is alive. So your data will vary every time you query for it. Okay, great. Good overview. Wednesday we'll talk about the midterm. Hey.
This set.
Okay.
So from the radius element of synchronization, it takes, I don't know how you say it, the big O-N.
Right.
To get a certain position only takes
one.
I don't understand why, because isn't it the same thing if you go into a position, you either return it or you add something. So it seems like the adding or returning should cause different attacks. It's a different method of getting to the position.
So adding in a position, so if you want adding, right, it requires you to actually potentially allocate a new array. But this actually moves the elements inside. So this is an insert. So when you insert, I have to allocate a new array. That's one bit. Right, and I have to copy everything over. just removing the existing thing, then it's okay. But you know, don't worry about this because the actual structure layout of it, you know, we're not going to be focused. Yeah, absolutely.
Okay, well maybe this is the same sort of thing, but for a hash set, you have a collision of those two parts, two percentages.
Yeah.
How is it?
Yeah. So if you have a hash like set, right? So there might be an hash code for some element E1 and also E2. So this H code is going to be a linked list and it's going to contain E1 and it's going to contain E2. So the first thing we'll do is we'll find the H code and we'll find this linked list. And then it's going to traverse it and it's going to run dot equals on each one of them.
It's like more
So if you're gonna compare, you're gonna say, does my hash set that contains E? Right? It's gonna do E dot hash code is this thing, and it's gonna walk across it, and then dot equals E1, E dot equals E2.
That's good resume.
Yep.
Yeah, I'm really, because I've got like really good work.
So we're gonna do QA on Wednesday, actually. So if you want to do it then.
I don't want to like half-ass it. I've got a bio course that's supposed to take 12 hours extra. 12 hours extra.
Cow on.
Only the regular one. Not the special one.
Good cow. This cow.
What is a regular You're so regular all of a sudden. Whoa.
It's not that. It's not I don't even know what
Lucky you.
I don't know what
Oh, really?
No.
Was it that worthless?
Yeah. You didn't pay $40 to rent a gown.
Paperweight.
It's not even a paperweight, it's a piece of fucking paper.
Marty can have this
Minutes?
Oh, see?
No way.
Like the whole thing.
research. Research.
90 minutes? Oh, you're just gonna distract me. Thesis defense is 20 minutes.
It's like in the first
90 minutes? That's not even, are you sure?
I mean, every person presents like once a week in our lab meeting. It's 2 hours long, half an hour we discuss that.
Is that what that is?
Oh, you gotta go.
No. Oh, actually, yeah. This is nothing. I'm taking my lab meetings. But like,
My friend's visiting for like a week and she leaves the day before that. And the day before that is when we have our 8-hour. I'm excited.
I didn't have 8 hours. 3 hours.
Well, it's like 2:30 to like.
Oh, yeah.
It's next week.
I was there. Instead of only 3 hours. I think on our rotation for like 45 minutes. It was like 8 hours.
Was the lady from TV?